In this video, we're going to start talking about the law of cosines. So what we're going to do is basically establish the formula, see where it comes from, and we won't go through every single case because a lot of it is pure repetition. So we will cover everything that's needed though, and then to cover the other cases, it's really not even a matter of cases, it's just a matter of you show it for, there's three different forms of the law of cosines, and if you establish one of them, then establishing the other two is pretty much identical, just you start with a different side of the triangle. So anyway, let's go ahead and draw an acute triangle, and this will actually also cover the case of right triangles. So we'll have an acute triangle here, and then we'll do obtuse triangles separately. So it's actually just the obtuse angle that we have to worry about. But anyway, we'll worry about that when we get there. So this will be angle A, this is angle B, and this is angle C. And then sticking with the convention, the side opposite angle A is going to be little a, this side will be little b, and this side will be little c. Okay, so now what we're going to do is establish one of the equations for the law of cosines, and then we'll go from there. So let's go ahead and drop a perpendicular from B to little b. Okay, so perpendicular, we'll call this H, okay? And let's go ahead and let's move this label here. So this whole thing, okay, this whole side right here is B, okay? So let's call this D, just for no real reason. So, well, now what we're going to do is label this. So if this is D and this is B, what's this going to be? Well, this whole thing is B, so take the whole thing, subtract this piece, then we're left with this piece. So the whole thing B minus this piece D gives us this. So this right here is B minus D. Okay, B minus D. Let's zoom in a little bit on that. So that there is B minus D. Okay, now what? Now let's cover this triangle up, and we see here in our right triangle we can use the Pythagorean theorem, and we can say h squared plus the quantity b minus d squared equals a squared. So let's go ahead and write that down. Zoom back out just a bit. So we can say h squared plus the quantity b minus d squared equals a squared. Okay, now let's use some right triangle trig here. So we can say, so now let's cover up this triangle and look at this guy over here. So two things we could say. The sine of angle A is the opposite over the hypotenuse. So sine of angle A is h over c. So let's go ahead and write that down. Sine of A is h over c. Okay. So multiply both sides by little c, and we get c sine A, capital A, equals h. Similarly, the cosine of angle A is d divided by c. It's the adjacent over the hypotenuse. So cosine of angle A is d over little c. Multiply both sides by little c, and we get c cosine A equals d. Okay. Now, why do we do that? Well, now what we're going to do is take these and stick them on up into here, and then see what comes out. Okay, so h is c sine of capital A. So this is c sine of capital A, that whole thing squared. Okay. Plus b minus, what's d? D is c cosine A. So d becomes c cosine A. And that whole quantity is being squared, and then that equals a squared. Now what we're going to do is expand this and simplify, and then what's going to come out of that is one of the equations from the law of cosines. So if we simplify this, this is c squared sine squared of a. And then here, what we're going to do here is FOIL. So remember when you FOIL, so this is something minus something else, the quantity squared. So this is x minus y quantity squared. And remember when you FOIL, you get something like this. Okay, so x minus y quantity squared is x squared minus 2xy plus y squared. Well, we're going to do exactly this, but instead of x and y, we have b and c cosine a. So this is our x, and this whole thing is our y. Okay, so when we do this foiling out here, what are we going to get? Well, we're going to get x squared, but x is just b, so it's just b squared. Oops. B squared, and then minus 2 times x, but x is just b, times y is c cosine a, and then plus y squared, plus c cosine A squared still equals A squared. Okay. So again, we're just doing foiling here. So x minus y quantity squared, that's it's foiling because you're really just saying x minus y times x minus y. So then when you do first, outer, inner, last, and you simplify, you just get this here. And with b and c cosine A instead of x and y, it just becomes this. So anyway, that's that. Now, let's go ahead and simplify a little more. So this is c squared sine squared A plus b squared minus 2bc cosine A plus, so then this, just like this became this over here, this is going to become c squared cosine squared of A. And then we have equals A squared. All right, now notice here, c squared sine squared A plus c squared cosine squared A. And then all this stuff here. So let's get these guys together. So this is little c, that's a little c. Little c squared sine squared of A, and then plus little c squared cosine squared of A. And then we still have the plus b squared minus 2bc cosine A equals A squared. Okay, now let's come back up here. All right, now why did we zoom out anymore? Nope. Okay. Why do we group these guys together? So c squared sine squared A plus c squared cosine squared A. Now let's factor, move down a little bit. Let's factor c squared out of that. So that becomes c squared times the quantity, what's left over? Sine squared A plus cosine squared A. Plus cosine squared A. And then we still have all this other stuff here. Plus b squared minus 2bc cosine A. Plus b squared minus 2bc cosine A equals A squared. Okay. So let's move up here now. Now, what is sine squared of A plus cosine squared of A? What is that? That's one of the Pythagorean identities from trig. So very, very, very important identity. One of the most important in all of math. Definitely want to remember that wherever we go in life. So now what happens is this becomes, this is just 1. So this becomes c squared times 1, and which is really just c squared, plus b squared minus 2bc cosine of capital A equals A squared. And this actually, this is one of the formulas from the law of cosines. So it's maybe more commonly written as A squared equals B squared plus C squared minus 2BC cosine of A. Okay, but notice it's exactly the same thing. We just switch the sides and then put the B squared first, but it doesn't really matter. So anyway, that's one of the formulas for the law of cosines. Now, there are two other ones. The other two are b squared equals a squared plus c squared minus 2ac cosine capital B, and c squared equals a squared plus b squared minus 2ab cosine of capital C. Okay. Now, how do we get these two? Well, how do we get this first one here? What we did was we dropped a perpendicular from B to the opposite side here. To get these other two, just start over with the fresh triangle and then drop the perpendicular from A to this other side, okay? Then you can use that, do the same thing, call one of the pieces D, call the other one B or A minus D in that case. Do the same kind of thing here with the sines and cosines. And if you do that, then you'll get one of these other two. It depends on how you label it. Okay, so we could have called this piece D and this piece B minus D. Then we would have gone a different route and we would have gotten one of the other ones here. But anyway, and also to get the third one, drop the perpendicular from C to C and then label it like we did over here, and then do the sine and cosine thing again. And you'll go through all the same math. It'll be exactly the same. It'll be identical. You might just have different letters in different places, but the steps will be exactly the same. You'll have an equation just like this, except this might not be a B, this might not be an A, but you'll still do the same kind of thing, make the exact same substitution. You'll have this step here. You'll FOIL this kind of thing again. You'll combine like terms here again. You'll factor out, this might not be a C squared, but you'll factor this out and you'll get this Pythagorean trig identity there, and then you'll simplify and you'll get one of these other two. Okay. So that's how it works for acute triangles. Now what's nice though is this also works for right triangles, But what's different about right triangles is, what if we use this on a right angle? So let's just look at the first one here. What if angle A were a right angle? Well, then this would become a squared equals b squared plus c squared minus 2bc cosine of 90 degrees, right? So if A were a right angle, A would be 90 degrees. But what's the cosine of 90 degrees? Cosine, running out of blue. Cosine of 90 degrees is 0, right? Remember, so 90 degrees is pi over 2 radians, so if it's easier to think of it like that, that's fine. Cosine of pi over 2 radians is 0, cosine of 90 degrees, 0. So if that's 0, then this whole term goes away, and what you're left with is a squared equals b squared plus c squared, just like you would expect in a right triangle. Okay, so in a right triangle, probably help if we actually draw it. So if angle A is right, A, and this will be, I guess that'll be C, that'll be B, little b, little c. So if A were a right angle, then we would have, just from the Pythagorean theorem, a squared equals b squared plus c squared, right? And that's exactly what we get from the law of cosines in that case, because A is 90 degrees and cosine of 90 degrees is 0. So in a right triangle, the law of cosines actually becomes, or reduces to, the Pythagorean theorem when you apply it to the right angle, okay? To the 90 degree angle. So it's still going to be this form for the other two, because cosine of b and cosine of c, whatever they are, it's not 0, because these are not 90 degrees. Okay, so anyway, but b and c are acute, so even though this is a right triangle, to establish the law of cosines for the angle b and the angle c, you go through the exact same process. Just drop the perpendicular from A to the other side here, and then call one side D, call the other one A minus D, and then actually to do the other formula, you would just call this one D and then call the other one A minus D. Okay, but anyway, the point is, it's just a lot of doing the same exact thing over and over again, which is why we're not going through all the steps, because it literally is exactly the same thing over and over again, this exact process. Now, what's a little bit different is the obtuse triangle case. So let's go ahead and draw an obtuse triangle and see how that's different. So we'll set up our obtuse triangle. I think we were running out of blue. Yep. Let's draw it in green. Okay. Actually, let's not draw it like that. Sorry, let's draw it like this. Okay, so this will be angle A, this is angle B, and this will be angle C. So this is side C, this is side little b, this is side little a. All right, now what we're going to do is extend. So we're going to do the perpendicular thing. Now notice this is an obtuse triangle, one obtuse angle here, but two acute angles. So remember the law of cosines has those three different equations, and to establish two of them, you can just drop the perpendicular from the acute angles like you would normally, but or drop the perpendicular from here, okay, like you would normally. So drop the perpendicular from the obtuse angle to the other side. But now what's different is when we try to drop a perpendicular from, let's say, B or A really, the triangle doesn't, we have to drop it from outside the triangle, and that is going to change things a little bit. So let's extend the triangle a little bit here, and then we'll drop the perpendicular, not dropping it right. All right, that's a struggle. Okay, so that's a right angle. Now we'll call this H. Okay, and this part here, let's go ahead and call this D. So then this whole thing is B plus D, right? So if this piece is B, this piece is D, then the whole thing is B plus D. So already we see it shaping up to be a little bit different from the acute case. Okay, so in the acute case we had the whole thing being called something, and then this would be B minus D, and so on. And the difference is because we had to drop the perpendicular outside of the triangle, now we have this extra piece here. Okay, so anyway, now we're going to apply the Pythagorean theorem, and the Pythagorean theorem in this case tells us, well, what are we going to look at? So there's a right triangle here, right? But we're not going to focus on that one for now. We're going to focus on the whole right triangle here. So there's a big right triangle here. So if we ignore this side A, then we have this big right triangle here. And that's the one we're going to look at. So from the Pythagorean theorem, we have c squared, the hypotenuse, equals h squared plus, so this hypotenuse equals this side squared, this hypotenuse squared equals this side squared plus this side squared, and this side is h, this side is b plus d. So c squared equals h squared plus b plus d, quantity squared. Okay. Now we're going to do the same thing that we did before in the acute case, but now what we're going to do is, so this right here, this is angle C. So if that's angle C, then what's this angle in here? So let's move this D label to the outside. So here's D. So if that's angle C, then this is 180 degrees minus C. Okay? So now what we're going to do is the same kind of thing we did before, but now we're going to do it with this here. So we see it's getting a little more complicated, right? So what we're going to do is say, okay, now sine of this angle is opposite over hypotenuse. Sine of 180 degrees minus C is h over a. Multiply both sides by a, and we get a sine 180 degrees minus C equals h. Okay? Now also, let's look at the cosine. So the cosine of 180 degrees minus C equals what? The cosine of that is adjacent over hypotenuse, which is d over a. So the cosine of that is d over a. Multiply both sides by a, and we get a cosine of 180 degrees minus c equals d. So here, h is this mess here, and d is this mess here. So we can take this up here, stick it in for h, and this down here, stick it in for d. But before we do that, let's simplify that, because those are really messy and ugly. We don't really want to work with those. We can simplify now or simplify later. Let's simplify now. It'll be much better for us later if we simplify now. So how do we simplify? Well, let's think about our trig identities. So if we think about our trig identities, what is this? This is sine of one angle minus another angle. So in general, sine of, let's say, alpha minus beta is what? That's going to be sine of alpha cosine of beta minus cosine of alpha sine of beta. Okay? And we also, so we're going to use this trig identity from way back when. We're going to use that to simplify this. And also, cosine of this mess minus that mess, we're going to use the trig identity to simplify. So we talked about these trig identities several videos ago. So cosine of alpha minus beta is cosine of alpha cosine of beta plus sine of alpha sine of beta. Okay, so what do we have? We have sine of 180 degrees minus capital C. Okay, so this is our alpha, this is our beta. So this is going to be, so let's write that. This is our alpha right here, and this is our beta. So this is going to be sine of alpha, which is sine of 180 degrees, times the cosine of beta, which is cosine of C. Okay, so remember it's alpha minus beta, so beta is just the C, not with the minus. And then we have minus cosine of 180 degrees times the sine of beta. Okay, cosine of alpha is cosine of 180 degrees, because 180 degrees is the alpha, and then times the sine of beta. Beta is just C, that's sine of C. Now we have to think about the unit circle. Sine of 180 degrees, that's 180 degrees is pi radians, so if it's easier to think about that, sine of pi is 0. So this whole term is 0. Okay, 0 times cosine C is 0. And then what we have is 0 minus cosine of 180 degrees is cosine of pi radians, which is negative 1. So 0, this whole thing is 0, and then minus, okay, minus, and then this is negative 1. So negative 1 times the sine of C. So this is 0 minus negative sine of C, which is just positive sine of C. So that is great because now sine of 180 degrees minus C is sine of C. Okay? So this is actually a fact that we've used several times before, but this sort of establishes it using trig identities, and it's nice to go through all the details when working on a proof like this. So actually we can simplify this and say h equals a sine of c. Okay, because what we just saw was sine of 180 degrees minus c is sine of c. So if we slap an a in front of that, the a is still there. So if h is a times this, and this equals that, then h is a times that. Okay, so now let's do the same thing with the cosine. So the cosine, let's maybe make some more room here. So with the cosine, we have cosine of 180 degrees minus c. And again, why are we doing this? We're doing this because we want to stick these expressions into this equation here, the Pythagorean theorem. But these are too messy. We don't want to use these with 180 degrees. We want to simplify them if we can, and then put them in here like that, and that'll be better. Anyway, cosine 180 degrees minus c is, so here's our alpha. And there's our beta. So this is cosine of alpha, which is 180 degrees, times the cosine of beta, oops, beta is just c, and then plus the sine of alpha, sine of 180 degrees, times the sine of beta, and beta is just c. How does that simplify? Well, same values as before. Cosine of 180 degrees is -1, so this is -1 times cosine of c, plus sine of 180 degrees is 0, so this whole term is 0. So this is just negative cosine of c, okay? So then what we have is d equals a times cosine of 180 degrees minus c. We just found out that this cosine here, cosine of 180 degrees minus c is negative cosine of c. So what we really have is a times negative cosine of c. So a times negative cosine of c, which is just negative a cosine c. Okay. So that's great. That's much more simplified. Now we can take these, h equals a sine c, we can stick it into there. D equals negative a cosine c, we can stick it into there. That's great. That's wonderful. Let's go ahead and do that. So then what we get is c squared equals h squared. Oh, we're going to have to erase this. C squared equals h squared. What's h? H is a sine c. Okay. So this is a sine c quantity squared plus b plus, but d now is negative a cosine c. So this becomes negative a cosine c, that quantity squared. But plus a negative just means minus. So that's minus. Now you might notice though that this really is identical to what we had earlier. Okay, but earlier we had c sine a and we had b minus c cosine a, but it's exactly the same thing because the math is going to be all the same. We're going to simplify this and then FOIL this and simplify that, and then combine like terms, get the sine squared and the cosine squared. So it's really going to be identical to what we already did, and that's going to complete everything because that covers what to do with the obtuse case. So with the obtuse case, you have this extra step of simplifying this mess here to worry about. And if we didn't simplify it now, we would have to simplify it later. Okay, so we could either do the trig identity thing now or put these two messy things in here, expand all that out. That's going to be terrible. And then we can simplify with trig identities later. Definitely not a good idea. Definitely want to simplify these first. Okay, but anyway, when we do that, we still end up with the exact same type of expression. So even in the obtuse case, it really is still the same. You just have to take an extra step of using the trig identities. You have to take that extra step to get there. But just for the sake of being thorough, we'll go through it again because it is kind of messy, so it's good to see it at least once, or at least twice, I guess. So anyway, this is c squared, but that is pretty much it. So if you want to skip that part, that's fine. That's pretty much the end of the video. There's nothing new after this, just going to be more of the exact same algebra we did before, and that will establish the law of cosines. And then in the end, we'll summarize again what the statements are. So anyway, this is c squared is a squared sine squared of capital C plus, when we FOIL this, so remember foiling, that's going to be x minus y quantity squared is x squared minus 2xy plus y squared. Okay, so here's our x is just b, and then this whole thing is our y. So x squared is b squared minus 2 times x times y plus y squared. And then that's it for that step. Okay, now let's expand and simplify. So that's c squared equals a squared sine squared of c plus b squared minus, so now 2ba, what I'm going to do is rewrite that as 2ab cosine of c, just because that's a little more standard, and that's going to more closely match the form of the final equation. Plus, this becomes a squared cosine squared c. So notice it's really all the same as it was before in the acute case. So then what we have is this type of mess that we had before, and now what we're going to do is put this guy together with this guy, and we're really out of room up here. So then what we get is c squared equals a squared sine squared of c. So we'll put that guy with this guy, a squared cosine squared of c. And then plus the b squared minus 2ab cosine c, minus 2ab cosine of capital C. So then c squared equals a squared. So factor out the a squared, and then from these two guys here, and what's left? What's left is the sine squared of c plus the cosine squared of c. So we have sine squared of c plus cosine squared of c plus the b squared minus 2ab cosine of c. Okay, so now c squared equals, so sine squared of c plus cosine squared of c is just 1, right? So remember, that's the really, really important Pythagorean trig identity. That's just 1, so that's a squared times 1 plus b squared minus 2ab cosine c. And this right here is one of the formulas from the law of cosines. So that establishes this one for the obtuse case. For the other ones, you would just drop another perpendicular down here, and then you would just call this part h, and then this part could be d, and then this whole thing would be a plus d. And then you go through the exact same thing again with the sines and the cosines and the trig identities. And then for the third one, you can just drop the perpendicular here, and then it'll be treated just like the acute case, because you would have this whole thing as c, you can call this d, so this would be c minus d, and so on and so forth. So three cases to treat separately, and that's what you would have. So that's pretty much it for the law of cosines, and let's rewrite what they all say just to be thorough. So just to recap, it's a squared equals b squared plus c squared minus 2bc minus 2bc cosine of capital A. B squared equals a squared plus c squared minus 2ac cosine of capital B. And lastly, little c squared equals little a squared plus little b squared minus 2ab cosine of capital C. Okay, so that's the three equations for the law of cosines. And starting in the next video, we'll talk about how and when we use it, and we'll see some examples. So that's an explanation of the law of cosines.